So, good morning students. Here we start with part 8, which is basically it will deal with the cardinality formula of set theory. So, it deals with the cardinality formula of the set theory. The cardinality formula are based on the rule of cardinality only. So we will write a couple of formula first and then we will try to establish this. Say n of A union B is equal to NA plus n of B minus n of A intersection B. So this is the very simple cardinality formula we get from here. So I think this part you can see, or I'll remove this a little, that would be better for you. N of A union B is equal to n of A plus n B minus n A intersection B. So here the board is a little bit of glossy, so this is n of A union B. Next, if I write A union B union C, cardinality of that, it will be NA plus NB plus NC, then minus n of A intersection B minus n of B intersection C minus n of C intersection A plus n of A intersection B intersection C. So actually there are there could be many cardinality formula. There is no end to it. As per the situation, we design or we write our own formula. Okay. So the main way of writing a cardinality formula yourself is to study the Venn diagrams properly. Say I'll give you some example. If I want to write n of A minus B, then what shall I write? Now first let us learn a little bit of it. Number 1, n of A union B, that means what? Say if I draw simple Venn diagrams, say 1, 2, 3, then 4, 5, say 7, 8, 6, 7, 8, 9, 10, 11. Okay, so this is A and this is B. So how many elements total you get for NA union B? If you count all the elements, you will get 11 elements. Okay. Now only A will give you how many elements? 5 elements. And only B will give you how many elements? Please count. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So you can understand that if you add up these two, NA plus NB, you get 13 over here. Okay, which is not equal to this 11. So you need to subtract this part, n of A intersection B. N of A intersection B, how many elements are there? There are 2 elements. So when you subtract this from this, that means you do a 13 minus 2, you get 11. So that is how the law or the formula is proved over here. So what we do basically, so why do we subtract? We subtract because this part is actually counted twice. When we add up NA plus NB, this part is the elements 4, 5 is counted twice. First for A and then for B, it's counted actually twice. So that's why we are subtracting it once so that the left hand side and the right hand side match up properly. So this is the justification of formula number 1. Now you can look at it very carefully. Okay. Now if I try to establish this formula number 3. Okay. So try this. Okay. So look at it. When you count NA union B union C means this whole area. NA union B union C means the whole area. Whichever elements they are existing, you have to count once. Okay. Now, when you count NA plus NB plus NC, just look at this. This middle part is, these parts are twice calculated, twice counted. Okay. Now, since A intersection B is twice counted, or A intersection C, this part is twice counted, or say B intersection C, this part is also twicely counted. So we subtracted this A intersection B, B intersection C, and C intersection A out of the NA plus NB plus NC. Now in doing that, we subtract these three areas means what happens to this middle area? See, when you take A, then plus B, then plus C. When you take A, then plus B, then plus C, the middle part is thrice calculated. Okay. The middle part is once taken for A, the middle part is once taken for B, and the middle part is once taken for C as well. So actually the middle part is thrice calculated. But when you are subtracting this A intersection B and then B intersection C and C intersection A, one by one, what happens? The middle part is also subtracted thrice. So first of all it was added thrice, and then by writing these things it got subtracted thrice. So that means the middle part is not at all calculated. So that's why we add it once. That's why we add it once. If you put some numbers into it, 1, 2, 3, 4, then 5, 6, then 7, 8, then 9, 10, then 11, 12, 13, okay, then 14, 15, 16, okay, then 17, then 18, you will get the justification. You count it properly, you will get the justification, but you have to understand why it is happening so. So now another way, better way of understanding this, maybe you can cut three circular papers of different colors, or you can see you can take three tracing papers also, okay, or any translucent paper. So you can overlap them one upon each other, and when you cut out three parts of this part, then this part and this part, you will observe that there is a hole created over here. A hole created means you need to add up a small piece to fill up the hole. The hole created over means you have to add up a small piece to fill up the hole, and that small piece is this one. That small piece is this one. So you can try proving this. Okay, so these are mainly the Venn diagrams we have to understand, and if we can understand the Venn diagrams properly, we can write the cardinality formula properly also. Let us see n of a minus b. So you always know that n of a minus b means what? It's a kind of subtraction operation. I told you subtraction operation means when you write a minus b, it will denote this part, this crescent part, okay, a minus b. That means if someone does like na minus nb, that is actually wrong. That is actually wrong. Why so? Look at it. Na is how much? 5. Nb is how much? 8. So if you do a 5 minus 8, then it becomes minus 3. So which is not correct. So what we have to do, we have to subtract, instead of writing this, we have to write something like n a union b. That means the whole thing n a union b minus nb. Then it is correct. n a union b is how much? n a union b is 11. And when you do a 8 subtraction, that is nb, you get 3. So that becomes correct. So these are the cardinality formula you get as per situations. Okay. So now we will see a very simple sum. We will write up a simple sum and try to just analyze how the cardinality formula are working. So I write a sum over here which says that a committee existing. So in that committee, this is the data. 50 people speak French, 20 people speak Spanish, and 10 people speak French and Spanish. So what is the question? That how many people, so you can write the question that how many people speak at least one of these two languages. How many people speak at least one of these two languages? Okay, so this is the question. Now see, so if I take n of f means what? That is 50. And if I take n of s, which is Spanish, f means French, that is 20. And this is the data given in the question. And n of f intersection s. Why f intersection s? Because you know that French and Spanish, so and is specified by intersection, so that is the common part. So f and s will be 10. So now we have to find what? We have to find at least one of these two languages. How many people speak at least one of these two languages means, if you draw the Venn diagram, they can speak, this will be the thing, f union s. Why so? Because they can speak only French, they can speak only Spanish, they can speak both. Every case you have to consider. At least one means either one language or more than one languages. So this will be kind of, you can write the formula first, nf plus ns minus n of f intersection s. The same thing I have written, I have only just replaced the initials by f and s just to make it easier so that it becomes more relevant to the sum. So you can put this 50 plus 20 minus 10, so you get a 60. So this 60 is our answer of the question. Now what I will do, I will add a little twist to this question only. Okay, so you study this properly. What I'll do, I'll add a little more part with it. So first let me rub the top part, and after that we can proceed. So see the second part of the question which I wrote on the board, is the number 2. So what I wrote here, that the same question I have modified a little, that French speaking people remains 50, Spanish speaking people remains at 20, and both speaking people, that means the French and Spanish, remains at 10, and no language is spoken. This I have added, that is 5. Now the question is, how many people are there, like surveyed, how many people are there in the committee? Okay, maybe these people like 5 people, they speak English or something else. So the question is, if this is the data, how many people are there in the committee? So in this situation what will happen, look at it, we are doing this f and we are doing this s. Okay, so f intersection s, so you know f intersection s is 10. So this is how we draw the Venn diagrams. F intersection s will be 10. Now only f, obviously you have to subtract this out, so it becomes 40, because together it will make 50, and this will become 10, right? So this is, so since you got from the previous data also that n of f union s, you got a 60. Now no languages means this will be in this outside area, that means in this dotted area, which is, you can take 6 over here. In the dotted area you can take a 6. So that means the universal set is u. So you can take a 6 over here. So that means how many people are there? So you have to, if you want to take u, you have to unite these two parts. That means n of f union s and you have to add up this n of f union s whole dashed. So that means this denotes what? This people who actually do not speak any of these languages outside f union s. That means no Spanish and no French. So you get a 60 and sorry, this is 5. Sorry, this is 5. So the 60 plus you get a 5 over here. So the total people in the committee will be 65. The total people, the committee will have 60. Okay. So next we see another sum. Question 2. Here we find that out of 100 students, these are the data given. 50 passed in English. Okay. Then 12 passed in maths, 8 passed in science, 6 passed in E and F means English and maths. 7 students passed in maths and science, 4 students passed in English and science, and this 4 students passed in all three of the subjects. Now the question is, you have to find out how many passed in. So number 1, how many passed, okay, in English and mathematics but not in science. English and mathematics but not in science. So this you have to find out. English and mathematics but not in science. So here if we draw this, so it looks like kind of this situation where, okay, so this is for English, this is for say maths, and this is for say science. So English and maths means they are actually trying to denote this part, okay, but not in science. That means from this part you have to remove this small part. Are you getting? So that means our shade becomes this. So the question which I have written on the board, English and maths but not in science. So this will be kind of this. So how many passed in English and maths but not in science? So as you see the data given, so we have to find what? We have to find this shaded region. So it's very easy for us. So what we will do, we will just do n of E intersection M, which is already given to us, this thing, this 6, okay, and minus we have to do the middle part. That means n of E intersection M intersection SC. Okay, so I have denoted, let me write S. I have denoted EMS as the respective sets. So here we do a 6 minus, so all three you can see it's a 4 given. So 6 minus 4, it will be easily 2. Okay, so 6 minus 4, it will be easily a 2. So 2 is the answer of this question. Okay, now next question. Next question is, how many students passed in maths only? Okay, so I'll write over here, how many students passed in maths only. So when I do a maths only, that means, look at it. So you have to find out how many students passed in maths only. That means you have to exclude English students. That means only maths, one subject they are asking for. You have to also include the science students. Okay, so it will be kind of this dotted area. Look at the shade. Okay, it will be this dotted part. So that will be, so how to find out this dotted part? First you have to take the whole of maths. Okay, from whole of maths what we do, so I'll erase this thing, then it will be easier for you. So from whole of maths I'll erase this part, then it will be a little easier for you. Yes, from whole of maths I am first subtracting this part. I'll use a different color. Okay, I'll subtract this part, this green part. Okay, are you getting? That means I subtract what value? N of E intersection M. Okay, now also I will subtract this part, the red part. Just see, that is I will subtract N of M intersection S. So in doing that, don't you think that this middle part is subtracted twice? Right? The middle part is subtracted twice. Look at it. Once it is written with, it is shaded with the green ink, and secondly it is also shaded with the red ink. That means it needs to be actually subtracted once, but we are subtracted it twice. So that's why we must add one back. That means what I do, I add up E intersection M intersection S back to the whole formula. So now let us put, so max will be 12 minus E intersection M, which is this 6, minus M intersection S, which is 7, and at last adding this 4 with it. So find out the result, what it becomes. It becomes 16 minus 13, and you get a 3 over here. Okay. So this 3 is the answer of only maths reading students over here. So this is how we proceed with. So basically you have to understand. See, this formula we have never written earlier. So this time only we wrote the cardinality formula. So better you have to understand the Venn diagram and then proceed with the formula and develop your own formula. So next we can always see few sums from NCERT exercise